Good evening, January 27th, and it's late night. On the other hand, I just felt like solving problem 3, so let's see if I can do it. It's to prove lemma 1 for even n and the odd case treated in the text. What we have to prove is this formula and the definition of chi n mark, and it's a character modulo 4 n naught, where n is even, it's 2 times n naught, and n naught is square free. And the definitions of g of chi n mark and g of the Dirichlet character, how that's defined. It's slightly different as we see, or rather the linear character or additive character is different. Well, on page 9 we get the solution that we shall apply the isomorphism, that's the Gaussian integers modulo 4 n naught is equivalent and we've been through this before. I don't think I've made all the details of the argument that it will hold in any Dedekind domain, but I'm sure you can make those details yourself. And when these coefficients here x and here x1 and x2 roam through the residue classes, we of course left them to some Gaussian integer. All right. So we changed the sum for this. And chi n, we use the definition. Oh, that's an x. And the Dirichlet character. And this guy, we'll just write it up. And n mark, I haven't written that here. Oh, that's 4 n naught. Yeah, I did write that. 4 n naught. That's the guy here. Oops. And then the real part of x1 plus the real part of n naught x2. Chi 2 is a character, I didn't write that, modulo 4, which I believe we had from the previous exercise. So that means it's chi 2 mark of n naught x2 and the Dirichlet character is a character modulo in naught. So this becomes 4, character 4 times the character fx1 over in naught. And then we split this. Here we have the n2. We take the x2 part, we take n naught out to cancel here. And here times 4x1 All right. Now what do we need here? Chi2 of n naught that is actually minus 1 modular n naught. I made a table where you can see it. I don't know if there's light enough on it. Let's check. So here we have the table of chi. Oh my God, it's difficult. Of chi2 and the real axis going out here, and you can see it's 1 and minus 1, and then it's a character modulus 4. So that modulo 4, so that will repeat. So it just equals this guy, and we can put that outside. And then 4, that can actually give minus, that is of course a square, so that's unity. Okay, and then this guy, this gives unity. So chi2 times 1 divided by 4 real x2, that's g of x2 mark, or chi2 mark. And what's left here now, what did I do wrong here? It's the real part of x1 No, it's not. This doesn't really make sense, does it? Oh yeah. What we should take here was to take the norm of the guy. So this is the norm. So I was wrong there. We should take the norm. So a little more computation is needed there. Yeah, 4 n naught times something plus and then n naught squared x2 bar. Oh, and it's all modular n naught, so it's just equivalent to 16 times the norm of x1 modulo n naught. And where did the 4 go? Oh, that's the square, of course. And it should be 16, which is even more a square. And then times the norm of x1. And then we should have 2I divided by n naught times, that's the real part, and that should have been the trace. Which is twice as much. Now let's see what we've got. We use green for that. This part agrees and this part agrees. So it's the last part that fails me. We have the norm of x divided by n naught times e 2 pi n 2 pi I divided by what happened with the 4 down here? Well, that's one thing. So I get 4 down here. So we are factor 8 off. That, well, maybe that factor 4 is wrong. I will take a little break, I think. And it's late night, so I'll pour myself a glass of wine and then I'll try to find the mistake. So see you in a second. Well, I found the error. This trace x, oops, it should be like this, and trace x, oops, is defined to be the real part of x divided by n naught. And therefore it agrees. This is what I find difficult to correct, so sorry about that. But that was, having learned the technique, it was simple. So this exercise was simply to prove that I know how to do this. All right, good night.